for these last two examples, we're just going to revisit this whole idea of the time differential. We're just going to reinforce what we did yesterday. We're not learning anything new, just some additional problems, samples for you to see to help you with tonight. Then Friday and Monday, we'll wrap that all up together and then take our test next week. All right, here we go. Do you remember, was it last year when that pipe underwater burst out off of Huntington and they had that slick out there? It was, okay. So I remember when a ship called the Exxon Valdez had a huge oil spill and just devastated parts of Alaska out there. So once that oil gets on top of the water, it just spreads super thin, but this huge, big spread. All right, so imagine that oil slick is perfectly circular. Okay, just, because it could happen, right? It could happen.
In a perfect world without friction.
In a perfect world, it would be perfectly circular. All right, so we're just looking ahead at this problem. We've got some values, but the question is, at what rate is the area? Okay, so using those clue words, at what rate is the area? So I need to start with an area of what shape?
A circle.
All right, so I start with the geometry that we know, the area of a circle. And then this circle is changing. It's growing as the oil continues to leak. And so we put this problem into motion. And the only variable, yes?
This is like a general question.
Yes.
How do we know what equations we need to know and what?
Okay, so general question. How do I know? So I'm going to say generals, like you should know the area and circumference of a circle. You should know the area and perimeter of a rectangle and a triangle. You should know the volume of a sphere. Well, maybe I'll give you that. You should know the volume of a cylinder for sure. Okay, cylinder, the shape of the bottom is circular, pi r squared times h. In general, all volumes are the shape of whatever the bottom is times the height. So if you're dealing with a pyramid, the shape of the bottom of a pyramid is a square. So you have x squared times the height. Now the pyramid comes to a point. Remember what I told you yesterday about that?
So then you take 1/2 of it?
Not 1/2, the ratio is 1/3.
Oh,
Okay, so for a cone, it's the same thing. If a cone has a circular bottom, but then comes to a point, that would be 1 pi r squared times the height, and then 1/3 because it comes to like that. A tetrahedron, do you know what shape the bottom of that is? It's a triangle. Okay, you know the shape of a triangle, area of a triangle? 1/2 base times height. Okay, and then times the height of that,
1/3.
times 1/3. Right, everything is times 1/3. But I probably give you things related to spheres. Okay. Right, the only variable we have here is r, so my derivative is going to be 2 pi r, which everybody should know what 2 pi r is, right? Circumference, but also what is in addition to that? Times, okay? The variable changing, the rate of the radius changing. Okay, the radius is always continually changing in this problem, then which affects the area. All right, then we drop our values in. Where do I put the 3.5?
At the D.
Okay, so 3.5 goes here. All right, where do I put the 150?
To divide it by 2. And
Okay, it's kind of a trick question. Where do I put the 150 technically? Nowhere. All right, because 150 is related to the diameter, and what I need is the radius, and so the radius that would go in would then be 75, and then we have 2 pi, and then dA dt. And so I already have what I'm looking for alone, and so this would be regular old geometry. And since I like fractions, I'm going to do 2 pi times 75 times, what's the fraction for 3.5? 7/2. And then when I do that, I can reduce the 2's, and I just need to know what 75 times 7 is. Okay? You know what 75 times 2 is, right? 150. So then 75 times 4,
350.
300. And then 75 times 6, 450. And then another, I got to do 75 times 7. That's how I do multiplication in my head. All right, so 450, so we're at 525 pi. Now we need units on that. Okay, is it meters? Okay, we are talking about the area, and so the area would be square meters, and the time would then be minute. Okay, so see how much you're getting better already at these. Okay, getting more, being able to establish that more quickly. All right, last one. I think we need a drum roll or something. All right.
It's a physics question.
Okay. We have two persons or two items in this. Okay, we have an observer and we have a train. Okay, the observer is standing still. Okay, the train is moving. The train is going in what direction?
Away from the observer.
Yeah, but it tells you what direction. Nope. The train is going in what direction? An eastbound train, okay? So east is going that way. Okay, so my train is going that way. The person is waiting south. So my person is down here, waiting. Okay, and we're forming a nice little triangle, all right? So if I have my train here that has passed the person, oh, that's fairly terrible. Okay, little smokestack. I don't think trains even have smokestacks anymore. All right, so T for train, P for person, and then we want the distance between them. Right, how fast is the train moving away from the observer? And so we're talking about the distance between the actual train and the observer, so we can call that x. Alrighty, geometry.
X squared equals T squared plus P squared.
Okay, Pythagorean theorem tells us that x squared equals t squared plus p squared. Okay, derivative tells me that 2x dx dt is equal to 2t dt dt plus 2p dp dt. Okay. There are 3 rates. Okay, Sydney, pick a rate and tell me what it's describing. Any of the 3.
dx dt is describing the change of the distance between the person and the train.
Okay, the change of the distance between the person and the train, and do you expect that change to be positive or negative?
Positive.
Okay, because the train is getting farther away. Okay, good. All right, Nick, pick one of the remaining ones.
Sorry, I zoned out.
That's okay. We're talking about the remaining rates. So Sydney already told us that dx dt is the rate of change of the distance between the person and the train. So pick one of the other remaining rates and tell me what it means. She already did this one, so you can pick one of the other ones, maybe? Want to hand off to somebody?
The train one?
Okay.
60.
Oh yeah, I don't even need to know the number. I just want to know what it means.
Oh.
What does dt over dt, d big T over d little t mean?
The distance the train is going?
Not the distance. No, it doesn't mean. Okay, the rate.
Yeah.
Okay, the rate at which the train is going. What is the distance the train has gone? Okay, which letter? We're not talking about numbers here. We're talking about what they mean. Which letter is the distance the train has gone? Okay, T is the distance the train has gone. Okay, and then P is the distance of who? And what does dp dt mean? Okay, the rate of change or the rate of movement of the person. And is the person moving? Oh, Okay, person is not moving, so we have 0. Okay, now we're ready to plug some values in. Okay, our values we have to plug in. We know that P is equal to 70. What about the other sides? We've got to be able to fill in all these sides according to the Pythagorean theorem.
Can't you do it with like the 60 and the 4? You're doing 60 meters.
Yeah,
miles
so
per
if
hour.
T stands for the distance the train has gone, is that explicitly given in the question?
No.
No. Is it implied in the question though? Okay, so what is the distance the train has gone in the amount of time that's gone by here? Okay, it's 60 meters per second times the 4 seconds that have passed, and so the train has gone a total of 240 meters. Once I know that, I can also figure out, using Pythagorean theorem, okay, how long the x value is, which would be the square root of 70 squared plus 240 squared, which works out to be, whoops, a nice number.
250.
Okay, works out perfectly to be 250 meters. All right, we have all the values we need now. So going back to our question, 2 times x, which is 250, dx dt, which is unknown at this point, which is what we're trying to find, 2t, which is 240, and then what goes in for dt? 60, and then plus 0. Okay, it was really 2 times 70, but times 0, so that eliminates that whole part. Okay, and then we can simplify to solve for dx dt. So my numerator would have a 2 and a 240 and a 60. My denominator would have a 2 and a 250. I can reduce the 2's. I can reduce the 0's by a factor of 10. I can reduce the 25 and the 60. You can just do all that with your calculator. Did anybody have a final answer?
288 over 5.
280, you're saying 8?
57.6.
I got 57 points.
Yeah, well, yeah,
That's just
57.6, and then I did that as a fraction.
yeah, that's great. 57.6 what?
Meters per second.
Meters per second. Good job. Good job. And that concludes first semester calculus. Thank you so much for participating. Okay, you have done it. We are more than, we've done 5 chapters. We only have 3 chapters more to go. And then we are done.